With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with a question which says a point charge Q is located at the center of a thin ring of radius capital R with uniformly charged distributed as minus Q. We need to find the magnitude of the electric field strength vector at the point lying on the axis of the ring at a distance x from its center, given that x is much greater than capital R. So let's try to visualize the given situation. Here we can see in the diagram a ring is having a charge of minus Q distributed over its circumference, and a positive charge small q has been placed at the center, and we have been asked to calculate at a distance of small x, this is small x, from the center of the ring a point let's consider as to be P. So at this P point we have to calculate the magnitude of the electric field strength vector. So for that we can see due to this positive charge a electric field will be in this direction. Alright, so we can write it as E plus Q, and due to this negative charge on the ring we can say electric field will be towards the ring, and let's suppose it has to be E of minus Q. Alright, so we can say now first we will write the magnitude of this two what we can say electric field. So we can write electric field due to this positive charge, so we can write it as, in terms of magnitude we can write electric field at point P due to this positive charge is given by the formula K Q by R square, that is distance between these 2 points is x, so we can write it as x square. Let's say this is our equation number 1. Similarly we will write the electric field intensity due to this negative charge over the ring. So we can write this formula as, we have already studied this, but before that let's define the direction of both the electric field. So since we can see electric field due to positive charge is towards right, so we can take towards right as positive, and in vector form we can write it as vector of kq by x square for this small electric field due to this small charge plus q. Alright, similarly for electric field due to this negative charge that is spreaded over the ring, so we have studied the formula, that is minus we have, since we can see the electric field direction due to this ring is towards left, so we can take it as negative minus k q x, that is distance between this 2 point, that is the ring, and the point P is x, and dividing it by x square plus r square, where r square is the radius of this ring. So we can say this distance is r. So from here we can say n raised to 3 by 2. So let's say this is our equation number 2. So at point P we can write, at P we can write net electric field can be given as E1, or we can say it as E plus Q and plus of electric field intensity due to negative charge. Alright, so this is what the value of net electric field we are getting, and if you substitute the values over here, that is we can write it as kq by x square plus of, or we can say it is minus kq x dividing it by x square plus r square raised to 3 by 2. Alright, on simplifying it further we can say this can be written as it is over here, and from here we can say this can be written as kqx dividing by, so if we simplify it further, so we can say x square, and here 1 plus r square by x square raised to 3 by 2. Alright, so this is how we are doing the simplification over here. So we can say kq by x square minus of, we can say kqx dividing by x cube can be this x square will come out of bracket as x square, as we can see this root and this 2 will get cancelled and cube is left over here. So from here also we can say r square by x square raised to 3 by 2. Alright, so we can write, alright, so from here we can say we can take the value of kq by x square as common out from both of this term, so we are left with 1 minus of, this can be written as 1 minus 1 plus of r square by x square raised to minus 3 by 2. Alright, so from here we can see kq by x square, and here it is 1 minus of here by using binomial expansion we can say this minus 3 by 2 can be directly taken on this side, as we know, since x is much greater than r. Alright, so from here, so we have neglected the terms whose value will be very much less, so we are left with this equation over here. So we can say this can be written as kq by x square, and in the bracket we can say 1 minus of 1 plus 3 by 2 r square by x square. Alright, so if we simplify we can get, so here we can write kq by this can be written as x raised to 4, and here we can write it as 3 by 2, and here can be written as r square by only r square will be left over here. Alright, so this is what the expression we are left with. So if we substitute the value of k as 1 by 4 pi epsilon 0, so we are left with 3q r square dividing it by 8 pi epsilon 0 x raised to 4, and the direction, since the value we are getting is as positive, so direction will be towards right. So this is what the net electric field value we are getting. In terms of magnitude we have been asked, so this is the answer to this question. So if we compare it with the options, so we can say option B is the right answer to this question. Here only the difference is that instead of capital Q, it is a small q that has been given. Alright, so that's only the differences. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.